Good afternoon. My name is Simone. I'm from Brazil. I'm from FEIPLAR, Composites in FEIPUR. It's a trade show on advanced materials that covers the South America. It is a pleasure to have you here to know a bit about our products, our companies. And I also would like to thank GEC for providing us this session so that you can show a bit about our continent. Okay, so we are going to present, first of all, we have this event with two presentations. First of all, I'm going to show you the winners of the Excellence Award we organize in Brazil, in South America. And then we are going to have two presentations. One with Herman KOKUBU, the KOHLENIA, Argentinian company, that is going to present new applications with advanced composites. And then Jorge Solinas from Texiglass, a Brazilian company that is going to talk about graphene. Okay, so first of all, I'm going to present to you, it's going to be very nice to present to you the winners, of our Excellence Awards. Okay, so this is our trade show in Brazil. We organize it since 2000. Okay. Our Excellence Awards covers three categories: finished products, suppliers, and personalities. But today, we are only going to present to you the finished products, because the aim of this event is to talk about new applications. Okay? So, we work with three categories of products: engineered plastics, composites, and polyurethane. So, the winner in composites in the technology, wait a moment, so many things to carry. Okay, so the winner of Best Technology Development in Composites was the tractor hood manufactured by Agrale. It used the technology of Alan Harper. So it is a piece of large dimensions and several extraction angles, and it was produced by injection. Previously, it was manufactured by RTM Light in several modes, and now only a single part, taking the production much more easy. Okay, reduce the weight and many other benefits. The other winning in the category Best Product Development in Composites. Well, I think I jumped just a moment. Okay, let's only check. Yeah, no problem. Okay, this composites cable ducts modular system, okay, it was created to offer another product in the place of metal and concrete parts. So it presents light reduction, okay, and also it is very, very powerful so that pedestrian can walk on it. So it's another innovation from G2 Innovation Company. Market innovation, pultruded profile for solar panel structure. So you can imagine how the solar energy has grew up all over the world, and in Brazil it was not different. Okay, so this was developed by a company in Santa Catarina, a state in São Paulo, in Brazil. Okay, And the result is in tests of traction, compression, shearing, and corrosion was excellent. The fiberglass is structured to support photovoltaic panels, replace traditional models in metals, concrete, and wood. And it offers 4 times greater durability, savings in logistics and in repair too. So it was another winner product. The solar energy is increasing a lot in Brazil. So the market for this structure is increasing too. So it was a very interesting product for us. University, gravity car project. So this car is trying to get the world record, okay? And it is only 11% to reach the world record. It is developed by universities, so it is in the category of universities. Okay. Oh, nice, gravity car. The next one, it's highlight in sales. Highlight in sales. So structured isothermal panel. Oh, this is a very good product subject because everybody wants to build a house in composites. And we have many developments all over the world. And in Brazil, we have already had many. So as many companies develop these panels, more consciousness, more knowledge we create about this technology to have more and more houses being built with this material. So for this reason, Sulfibra, it's a very important company in Brazil, has had a winner product too. The other product, polyurethane, it's okay. Memory flow, it's a polyurethane foam developed by Menteville. The benefits of it, it's a viscoelastic foam with soft body temperature and firm in the coat, allows the passage of air as it is open, and it doesn't produce heat. It does not require the addition of cold blue gel, and high permeability allows evaporation of sweat. So another product developed in Argentina, but it is being worked in Brazil too. Also in polyurethane, best product development, sport synthetic floor by Green Engenharia. Brazil is known as a country that doesn't take care of the athletes because they don't produce the sport, the floor for sports with the requirement that the standards requires, okay? So this company developed a floor with several benefits for the knees. So it is the first company in Brazil that developed a synthetic floor like this. So for this reason, it's the winner. Okay, this part here, T-Cross truck lead, it was developed by Fast Plus, okay? It is using honeycomb. Honeycomb. This kind of honeycomb is the one offered by BASF. It's the corrugated paper with fiberglass and a layer of polyurethane. Very, very light, very indicated for parts that does not require critical safety, but for parts that help the car to lose weight, a very good demand for the automakers nowadays. So another winner. University. The Centro Universitário Senac, very important in Brazil, Senac, has developed the project of this boat with the students so that the students can learn how to build a boat, how to work with materials, how to study fluctuability, and to study many other disciplines. So it's a very interesting project because it uses many of our materials, and it is going to be built, more boats to be distributed for other universities. Engineered plastics, best technology development, okay? Multi-tubes filtering element. This part can be used in many markets in which the filtering is necessary, okay? And why this product was the winner? Because it joined several processes, microporous plastics, molding of components in thermoset. Oh, my problem is the glasses. Can you believe that I am so young? You can see, and I don't need glasses to read it when it's very near me. And I have so difficulty in reading. That's the problem. I was with my glasses. Okay, so several processes, microporous plastics, molding of composites in thermoset, epoxy resin, seals of silicone and polyurethane, extruded PVC pipes. And these new elements with filtering properties much more advanced than the ones found in the market was only possible thanks to the mastering of molding techniques of thermoset and thermoplastics. And then it's finishing my part. This is a table for picnic. Who likes picnic? But what is interesting in this table, first of all, is that it has the accessibility for the wheelchair. And the other point, very important, is that it is all made of recycled material, 100% made of recycled material, okay? So in this category, the winner was the picnic table with accessibility. Then marketing innovation is a base for the mattress. In Brazil, wood, because we have much wood. So, but things are getting more difficult to cut wood. And this company had this wonderful idea to build the base for the mattress using polymer, 100% polymer, and a very good percentage of renewable content, recyclable content. Very strong. The bases can support mattresses of different sizes, and the bases are also collapsible, so you can change the size of it. Okay, so another good product in our opinion. And here is a band-aid, okay? It's a band-aid, and it has a membrane, and this membrane uses the PLGLA. So it's a university development. So another winner. So I just came here to present to you the new products, the new winner products, but I'm really motivated to call the next lecture that you are going to check. Very good applications will be shown. So please, Herman KOKUBU da KOHLENIA, please come here to tell our audience the news we brought us. So Herman is here. Herman, thanks to you. Thanks. Giorgio is the next. Giorgio, do you want to sit down? George Solinas from Texiglass, Brazil. Herman from KOHLENIA. Ah, okay. So, thanks for your presentation.
So, good afternoon, everybody. Thank you, JC. Thank you, Feiplar. I am here on behalf of KOHLENIA and BKComp. BKComp was, BK's Boom was nominated for this year's Innovation Award, and you can visit us right next to this conference room at the Industry Planet. KOHLENIA is BK's partner with expertise in composites, and today we are going to talk about applications of advanced composites in South America. Well, we are based in Argentina. Argentina's economy is well known to be dependent on primary products and agricultural manufacturers. However, we also have a very rich scientific ecosystem with 5 Nobel Prizes, 3 of them awarded to scientists. We also have a long history in the development of nuclear technology, and this propelled, in a way, metallurgy. But advanced composites remain kind of, through the years, underdeveloped. So how is it that we begin working with composites? Well, for us, space industry was the perfect incubator. Since our beginnings, we are involved with Argentina's national space plan, led by our space agency, CONAE. We, in particular, were involved in the development of the manufacturing process of pressure vessels type 3 and 5. CONAE could have purchased this technology from abroad, but instead they decided to start from scratch with us, and that gave us a deeper understanding of the whole technology. One of the goals of CONAE, apart from building a satellite launcher with these pressure vessels, is to transfer the technologies they developed to other industries. And here is where KOHLENIA's, with its mission, comes in. We use our experience and our know-how to develop our own products, like transmission shafts and the sprayer boom of BK. And I think BK's sprayer boom is a good example of technology transfer for an application that has a strong link to the needs of our region. Let me show you a short video about BKComp.
There are more than 8 billion people on Earth, and they all need to be fed. Agriculture production has the challenge to keep up the pace of food demand in a sustainable way, and spraying is a fundamental process of the harvest cycle. BKComp developed a long-span, lightweight composite boom for agricultural spraying that boosts productivity. The patented design combines the outstanding properties of carbon fiber composites, a modular architecture, and the smart use of other materials. BKComp.
Our boom's concept is based on, relies on the smart use of different materials. And it is based on 3 main components: film and wound carbon fiber tubes that are the best way to achieve working with low weight, adhesive bonded metal fittings to handle with concentrated loads of hinges and attachments, and SMC fittings for attaching auxiliary equipment and secondary structural members. Let me now give you a short overview of the whole development phase of our boom, from the definition of the requirements to the construction of the first prototype. Well, when working with composites, it is a good practice to start with the characterization of the materials with ohm coupons. As you may know, composite properties are finally defined during the manufacturing process. So maybe not all the tests that are listed here were performed within this project in particular, but they are all part of our experience with composites. And based on the results of this test, we establish design values for our design phase. And we also validate processes that are critical for our concept, for example, adhesive bonding. Well, with the design values, the requirements, and the operational conditions, we start with the structural analysis. First, with a preliminary sizing with analytical tools and based on displacement and deformations. Normally, composites admit large deformations, so if the structure meets deformation requirements, it is highly probable that it will also meet strength requirements as well. And then we perform more detailed analysis with numerical methods from critical parts of the boom or critical components. And we also calculate like buckling critical loads and accelerations, and optimize some other critical components as well. The last step of the development phase is the construction of the prototype. The prototype was thoroughly tested under hard working conditions on a test track. We instrumented the boom with accelerometers in order to study the stability of the boom. And why the stability? Because stability affects the quality of the spraying of the chemicals. If the boom oscillates too much or flutters or swings, then the quality, the distribution of the chemicals on the field will not be uniform, and it is not desirable. So the first question was, how could we measure or quantify the stability of the boom? And the best approach seemed to be the natural frequency. We took the raw accelerometer data. We processed the parameters, the data. We performed a fast Fourier transformation to obtain the natural frequency. And after some improvements and changes, we can say that our current design of the boom is much more stable than our first prototype, and it is also about 10% more stable than the one of our direct competitor. Well, that was a brief overview of the development phase of the boom. Again, if you have further interest, please visit us at the Industry Planet. Let's now move on to another opportunity related to our context. That led us to an innovative solution. As KOHLENIA grew, we start facing the challenge of reducing our waste output while also exploring new sustainable manufacturing processes. We focus mainly on out-of-autoclave manufacturing processes, and we also try to avoid the use of prepreg. Why? Because from Argentina, dealing with refrigerated logistics is always very complex and expensive. We found that there aren't any composite dedicated recycling plants in Argentina. We also didn't find any carbon SMC compound manufacturer in the whole region. And we discovered that most of our scrap is generated before the resin is cured. So we started using our uncured scrap of the film winding process to use it as after a proprietary process as molding compound, compression molding compound. So, as you can imagine, the benefits are straightforward. We can reduce up to 66% the waste generation. We have savings in waste disposal fees. We don't incur in material. We don't incur material or refrigerated logistics costs. And we don't have one of the major problems of high-performance composites recycling, that is traceability. With this method, we achieve very good, very interesting mechanical properties. Here, in this example, we are replacing an aluminum part with SMC recycled material. And we can reduce up to 85% the cost of the production cost of the part. And this part is currently being used in our sprayer boom. So, to sum up, we strive to broaden our R&D base. We strive to innovate with composites. For example, the recycling project started as an internal initiative supported by an undergraduate thesis that aided in the characterization of the material. And now we are continuing the development in partnership with the Technical University of Munich and another German company with funding of the German Ministry of Economical Affairs. We are also working with the University of Mar del Plata of Argentina in the development of composite hydraulic cylinders, linerless hydraulic cylinders. And with a company of the marine sector, we are starting to develop carbon fiber unidirectional cables. So again, let me invite you to the Industry Planet. Thank you very much.
Now, Giorgio, it's your turn.
Forward, this one. Hello. Good evening, everyone. First of all, I want to thank you for the opportunity to be here with you. I'm flattered to have received this invitation. And I have to thank Aspen Event and Simone Martins and JEC for this opportunity. In my presentation, I will not just talk about the advantage of graphene that are very well known and increasingly studied. First of all, I want to present plexiglass to you. After this, we will talk about graphene. I'm going to talk about plexiglass and what plexiglass expects from graphene and what plexiglass is doing to bring graphene to the everyday market. I present plexiglass to you, special technical fabrics. We have an area of 22,000 square meters and more 22,000 square meters to be built. Plexiglass was founded in 1986 with the aim of producing fiberglass, carbon fiber, and aramid fiber fabrics, especially for composites. The first product of plexiglass was a phenolic prepreg of fiberglass. Plexiglass is leader in Latin America and exports to all continents, including Asia. Plexiglass operates in several market segments, such as composites, civil construction, aeronautical, nautical, human prosthesis, oil and gas, and so on. We are proud to be sponsors of universities and technical associations like SAMPI and AUMACO, the Latin America Association for Composites. In addition, to be a strong contributor to university education and technology development. As I said, plexiglass exports to all continents. Here you can see some of our products. Fiberglass fabrics, carbon fiber fabrics. They can be plain weave, twill, bidirectional, unidirectional, hybrid, many widths, etc. All these fabrics can be impregnated with many kinds of resin. Braids. How you can see, this is a hybrid braid, carbon and glass. But there are many kinds, also many diameters. Tapes, many widths and applications. Composites, electric insulation, with textural fiber for thermal insulation, etc. Unidirectional carbon fiber fabrics and pultruded carbon blades for reinforcing bridges and beams. We also produce fiberglass rebars. Initially, I believed that the use of graphene in civil construction will not be viable because of price. But I realized there are many opportunities. Graphene can be incorporated into cement to ensure greater water resistance. Can also be incorporated into resin to make pultruded materials such as carbon fiber blades and fiberglass rebars, improving their properties. This can be an interesting research work and a search for economic viability. Our products are used also in medical equipment, like tomograph and X-ray equipment. This is a mammogram table. Here we can see clear how graphene can help. Greater transparency. Adding graphene to the epoxy resin, we will get greater X-ray transparency. Considering that we produce thermoplastic and thermoset prepregs, I can see many applications. Our fabrics are also used in race cars, like this one, made with plexiglass carbon fiber and drove by the well-known driver Emerson Fittipaldi. This car won the last Formula Indy preliminary held in São Paulo. In the market of aircraft and drones, I see many applications. Recently, Embraer announced that part of ExMobile. That's a new Brazilian drone factory. ExMobile and Embraer are taxi glass customers. So I think we have good opportunities for graphene. Aircrafts and drones. We can also incorporate graphene in our prepregs to improve the mechanical and electronic properties. Drones can be lighter and stronger. Also, the high electric conductivity of graphene can be leveraged to create new applications. For the time being, I can't go into more detail, but we are recently approached by a drone manufacturer company that wants a prepreg with graphene to improve the conductive properties of their drones. We know that the two most important advantages of composites are lightness and mechanical resistance compared with steel and aluminum. We know that graphene will add and improve these properties to composites, not just improving these two properties, but also giving more, like superficial resistance, abrasion, for example, and chemical resistance. So we can imagine the quality improvement and more application of a composite tank with the addition of graphene. We are very well equipped with a laboratory that is capable of doing many tests, including tensile strength tests. With that, we can do our tests and confirm the improvement given by graphene. Of course, the official result will be released by a certified laboratory. In order to introduce graphene into our products and demonstrate its real benefits, we received approval for our project with a funding of $300,000 by FINEP, which is a Brazilian government department for financing a technical project with a real chance of success. The objective of FINEP is to improve the technological development. Explaining more about our study with graphene and about FINEP. The project title is Development of Prepregs with Addition of Graphene for Manufactured Parts in Advanced Composites with Improved Properties. The general purpose of this technological research is to obtain and characterize a Brazilian impregnated composite consisting of an advanced matrix reinforced with continuous fiber and with the addition of graphene, thus presenting chemical, mechanical, thermal, and electrical properties superior to the conventional one on the market today. Such prepregs will be used to manufacture multifunctional nanocomposite parts with structural application in aerospace and aeronautics, automotive, light and heavy vehicles, and agribusiness sectors. We are very interested in adding graphene to our products, especially to our phenolic and epoxy prepregs, including thermoplastic prepregs. The first part of the study ended with the incorporation of graphene in a thermoset epoxy system and carry out initial tests of Raman spectroscopy, dynamic mechanical analysis, and thermogravimetric analysis, and scanning electron microscopy of the graphene from 2DM and an epoxy nanostructured resin. The main points are the following. The literature helped us to have an overview of the main available materials as well as well as their incorporation in polymeric matrix, or even in polymeric composite reinforced with fiber, giving great visibility and applicability for the manufacture of the multifunctional composites. Analysis of Raman spectroscopy combined with thermogravimetry and scanning electron microscopy concluded that supplier graphene has excellent quality, having well-exfoliated particle and possibly with few layers. In addition, it's important to mention and call your attention for the fact that we have the ability to measure this data, excluding the possibility of being graphene oxide or all other carbon material. The incorporation of the graphene particles in the epoxy matrix was made with the aid of state-of-the-art ultrasound, increased selected solvents. The specimens showed good homogeneity as well as adequate dispersion of particles in the polymeric matrix. We used 3 solvents: an alcohol, acetone, and an amide. The dynamic and mechanical analysis confirmed the increase of the glass transition temperature of the matrix from the incorporation of 0.5% in mass of graphene for 2 selected solvents, acetone and alcohol. The increase of the TG suggests an improvement in the properties of the nanostructured resin, as well as an increase in its surface temperature. Finally, we have to mention that the processing of the resin via amide reduced the TG of the composite, which suggests a worsening of the properties. Additional tests will be performed to investigate the reason of this reduction. Here we have the graphic with the TG analysis. This is just the first step. The next steps consist of the production of prepregs and thermoset fiberglass laminates from nanostructured epoxy resin with graphene. As you could see, in my presentation, I said many times multifunctional composites. The market is looking for multifunctional composites, not just lightness and mechanical strength, but really multifunctional properties like conductivity, strongness, resistance against incrustation and dirt, etc. Well, I end my presentation saying that we are strongly introducing graphene in our products, along with the most prestigious technical institutes of Brazil. And we hope to have good news very soon. Thank you for the opportunity.
Questions to me, to Herman, to Giorgio? No? So I'd like to thank you again, but I'd like to compliment that we are at your disposal to supply you with information on our country. If you wanted to receive information on any market, if you wanted to know about our countries, you can contact us and we can send you this information, okay? So thank you again for coming and for seeing we presenting our products. Thank you very much. Till the next opportunity. Bye-bye.